This video is brought to you by mywayteaching.com.
Conditions for the combination of atomic orbitals. So, some of the conditions are there. The first one is the combining atomic orbital must have the same or nearly the same energy. For example, so for this there is an example, that is combining means 1s orbital can combine with the another 1s orbital. 1s orbital should combine with 1s orbital, not with 2s or 2p other orbitals. Okay, so here because 2s orbital is higher than that of the 1s orbital, like that. And the second one is the combining atomic orbital must have the same symmetric about the molecular axis. For this there is an example, for there is a 2pz orbital of one atom, can it share and combine with the 2pz of another, not with 2px or 2py. Okay, next, the combining atomic orbitals must overlap to the maximum extent. So these are the some conditions of the combination of atomic orbitals. Next, there are the types of molecular orbitals. Molecular orbitals of diatomic molecules are designated as sigma, pi and delta, etc. Okay, so here sigma molecular orbitals are symmetrical. Sigma molecular orbitals are symmetrical. Okay, around the bond axis. Around the bond around the bond axis, while the pi molecular orbitals are, they are not not symmetrical. Next, coming to the, if internuclear axis is taken to be in the z direction, it can be seen that a linear combination of 2pz orbitals of the two atoms also produces a 2 sigma molecular orbitals. Okay, that is designated as 2pz and sigma star 2pz. So this is types of molecular orbital. Next, energy level diagram for molecular orbitals. What happens in energy level diagram? That is, we have seen that 1s atomic orbital on two atoms form two molecular orbital designated as sigma 1s and sigma star 1s. So in the same manner, 2s and 2p atomic orbitals gives rise to the following some of the 8 orbitals. Okay, which gives the 8 orbitals like antibonding and bonding orbitals. Okay, then here I will write some antibonding. In antibonding molecular orbitals, so there are sigma star 2s, sigma star 2p z, pi star 2p x and pi star 2p y. Okay, hmm. And for bonding molecular orbitals, here sigma 2s, sigma 2p z, pi 2p x, pi 2p y. Okay, so this is about the electronic energy level diagram for molecular orbitals. Next, electronic configuration and molecular behavior. What is electronic configuration of the molecule? The distribution of electrons among the various molecular orbital is called electronic configuration of the molecule. Here the stability of the molecules, and that way, what about that? Stability of the molecules. Okay, in stability of the molecules, consider that NB, it is the number of electron occupying bonding orbitals. This is then Na is number of that is occupying anti-bonding orbitals. In that first case, Nb is greater than Na. So when Nb greater than Na, then it is stable. Okay. And the second one is Nb less than Na, that is unstable. Okay. So more bonding orbitals are occupied, and so the bonding influence is stronger and a stable molecule results. And the second thing is the bonding anti-bonding influence is stronger and therefore the molecule is unstable. Next, some of the definition I will give. What is bond order, nature of the bond, bond length, and magnetic nature. The first one is bond order. Here bond order is equal to half into Nb minus Na. So this can be say that bond order is defined as the one half of the difference between the number of electrons present in the bonding and number of electrons present in the anti-bonding. So a positive bond order can be result when Nb greater than Na, positive when Nb greater than Na. It is negative when Nb less than Na. This is about the bond order. Okay. Next, what is the nature of the bond? Nature of the bond, see, coming to the nature of the bond, it may be 1, 2 or 3. Okay, that is single, double or triple bonds respectively. Then what is bond length? Bond length, the bond order between the two atoms in a molecule, may be taken as a measure of the bond length. Bond length decreases as bond order increases. Bond length decreases as bond order increases. Next, magnetic nature. If all the molecular orbitals in a molecule are doubly occupied, the substance is diamagnetic. For this, substance is diatomic when the molecular orbitals in a molecule are doubly occupied. When that is doubly occupied. Okay, it is diamagnetic. Next is one or more molecular orbitals are singly occupied. Molecular are singly occupied, that is called paramagnetic. Okay. Next, bonding in some homonuclear diatomic molecules, that is hydrogen molecule, helium molecule, lithium, carbon and oxygen molecule. In that, what is happens in the homonuclear bonding. Okay. Then first coming to the hydrogen H2. In this, the electronic it is having combination of two hydrogen atoms. It is formed due to the combination of two hydrogen atoms, and each hydrogen atom has one electron in 1s orbital, which is having only one electron. Okay. And the third thing is in there are two electrons in hydrogen molecule. Now there are the each is having one electron, so it is having the two electrons in the hydrogen molecule, H2 molecule. So which represents the sigma 1s molecular orbital, sigma 1s molecular orbital. So electronic configuration of hydrogen molecule, so that electronic configuration is equal to, for the H2, sigma 1s whole square. So the bond order can be of half into Nb minus Na, that is half. Okay, then 2 minus 0, which gives the 1, where 1 it is represents the single covalent bond. Okay. Next is helium. In this helium, the electronic configuration is 1s square. Each helium atom, it consists of 1s square. Each helium it should form like this. One each having the two electrons, so that total of helium molecule which consists of four electrons. Okay, and here these electrons will be accommodated in like sigma 1s and sigma star 1s. This is bonding and anti-bonding. So this can be written as helium electronic configuration sigma 1s whole square, sigma star 1s whole square. So that is the bond order is equal to half into 2 minus 2 is equal to 0. Therefore unstable and does not exist. It means unstable and does not exist. Okay, this is about the helium. So same thing to that of the beryllium too also. Okay, next coming to the lithium molecule Li2. So what happens in lithium molecule? So in the lithium molecule electronic configuration is equal to 1s square and 2s1. The electronic configuration lithium 2 is equal to sigma 1s square, sigma star 1s square, sigma 2s square. Okay, and here the bond order can be represented as half into 4 minus 2 is equal to 1. It means that the molecule is stable and there is no unpaired electrons. It should be unpaired electrons. It is a diamagnetic in nature. Next, fourth one, carbon molecule. Here the electronic configuration of carbon molecule is 1s square, 2s square, 2p square. Okay, and here it is a diamagnetic. Diamagnetic in nature, and so here it consists of both pi bonds because of the presence of 4 electrons in 2 pi molecular orbitals. Next, fifth one is oxygen molecule. That is O2. Okay, here the electronic configuration of this is 1s square, 2s square, 2p power 4, 2p4. Okay, here there are the molecule is clear that 10 electrons are present in bonding. For bond order you can see here half into Nb minus Na. So this is half bonding in that 10 electrons and non-bonding. So it is in anti-bonding present in bonding, and 6 electrons are present in the anti-bonding, so that it gives 2. Okay, molecule should be paramagnetic in nature. This is about oxygen molecule. Next, coming to the, this is the molecular orbit occupancy and molecular properties of B2 through Ne2. So okay, this is the figure. And next thing is hydrogen bonding. What do you mean by hydrogen bonding? Hydrogen bond can be defined as the attractive force which binds hydrogen atom of one molecule with the electronegative atom of another molecule. I will explain you in detail here. Nitrogen, oxygen and fluorine are the highly electronegative atom. See here, these are highly electronegative atom. Electronegative. Okay, they are highly electronegative atoms. When they are attached to hydrogen atom to form the covalent bond, the electrons of the covalent bond are shifted towards the more electronegative atom. So when H, consider HF, so that when H is with F, so there is a covalent bond. Okay, covalent bond is formed and the electron move towards more electronegative atom, that is towards the fluorine atom only. So the partially positive charge hydrogen atom forms a bond with the other more electronegative atom. This is forming with other electronegative atom. This bond is known as hydrogen bond. This bond is known as hydrogen bond. Okay, means partially positive hydrogen atom, it forming a bond with the highly electronegative atom, that is fluorine. So this is known as hydrogen bond. Okay, next, the please note down this definition. Hydrogen bond can be defined as the attractive force which binds hydrogen atom of one molecule with the electronegative atom of another molecule. Next, cause of formation of hydrogen bond. When the hydrogen is bonded to strongly electronegative element, this is the hydrogen. Okay, this is the strongly electronegative atom. So the electron pair shared between the two atoms moves far away from the hydrogen atom. It will move, electrons will move far away from the hydrogen atom because it is a partially positive. As a result, the hydrogen atom becomes highly electropositive. This becomes highly electro positive with respect to the other atom. Okay, so since there is a displacement of electrons towards the x and the hydrogen acquires, this acquires partial fractional positive charge. This is fractional positive charge. It will acquire, it acquires a negative charge. Okay, this results in the formation of polar molecule having the electrostatic force of attraction. Okay, which can be represented as H delta plus x delta minus, this is dot dot, and this is H delta plus. So here just note it down where the this is hydrogen bond is represented. This is the hydrogen bond. Okay, and where the solid line represents the covalent bond. Okay, got it. And next, types of hydrogen bonds. There are two types: intermolecular hydrogen bonds and intramolecular hydrogen bonds. Intermolecular hydrogen bonds, it is formed between two different molecules. It is formed between two different molecules of the same or different compounds. Different molecules of the same or different compounds. Okay, so for example, HF molecule, H bond in case of HF molecule, H bond in case of HF molecule. This is about types of hydrogen bonds. In that, next coming to the intramolecular hydrogen bond. In intramolecular hydrogen bond, what happens? So it is formed when hydrogen atom is in between the two highly electronegative atoms present within the same molecule. Okay, and the example here, O nitrophenol, and the hydrogen is in between the two oxygen atoms. This is intramolecular. I will write sorry, I will write here intramolecular hydrogen bond. I will erase it and I will write it. Okay, please note down this intermolecular hydrogen bond. Then I will write down the uh, intramolecular hydrogen bond. Now I will write down the intramolecular hydrogen bond. Example for this. This is oxygen. See, here it is formed when hydrogen atom is in between the two highly electronegative atoms present within the same molecule. So, for example, O nitrophenol, the hydrogen is in between the two oxygen atoms as shown in this figure. So, this is the end of the topic, where that is the types of the hydrogen atoms. Okay, thank you.